Okay, hello everyone. So today we are going to discuss potentiometer, like what is this device and how to compare EMF using this device. So before proceeding further, I'll revise the topic called potential drop per unit length. So in last class we have discussed that if in a wire current is I and its resistance is R and length is L, then potential drop in the wire will be IR from Ohm's law, and VCM is potential drop per unit length. And what will be the value of VCM? VCM will be potential drop divided by length of wire. And vice versa, suppose if you have a wire whose VCM is given and on length L, the question is what will be the potential drop on this section of wire? So VCM is basically potential drop divided by length. So potential drop will be VCM into L. So you have to remember this formula that if VCM is given and length L is given, then potential drop in the wire will be VCM into L. And you can replace this small part of wire with a battery whose potential will be VCM into L. So plus will be on this side, minus will be on this side. So plus will be on the side from which current is coming. So you can replace this part of wire with a battery of potential VCM into L. You have to remember this formula while solving questions of potentiometer. Okay. Now, if you look at this circuit, suppose there is a battery of EMF E1, battery of EMF E2 and a resistance R. We have to find out the condition when current will be zero. So we have to find out the condition when will the current in the resistor will be equal to zero. So what we'll do is we'll take current I from this battery, I will reach this battery and I will be there in the resistor, and again I will reach to the battery EMF E1. Now we'll take nodal points A, B, C, D, and we'll write Kirchhoff equation from A, B, C, D, A. So we'll write Kirchhoff equation from A to B, B to C, C to D, and D to A. So from A to B we have nothing. From B to C we'll get the positive terminal, so we'll write minus E2. From C to D, the direction of movement is from C to D and current is from C to D. So we'll write minus IR. And then from D to A, we'll get the negative terminal first. So we'll write plus E1 equal to 0. Now we have to find out the condition when current in this resistor will be 0. So putting I equal to 0 in this equation, what we'll get is we'll get E1 equal to E2. So remember, if in a circuit like this, two batteries whose positive terminals are in contact with each other and their potential difference is same, their EMF is same, then current in this resistor will be equal to 0, because the total increase in potential by this battery will be equal to total decrease in potential due to this battery. So there is no potential difference across this resistor, so current in this will be equal to 0. You have to remember this diagram by heart, that in this kind of diagrams, what will be the value of current in resistor if EMF of both the battery is same. But remember, the positive of this terminal, the positive of this battery should be connected to the positive of this battery. Okay, now how will you use this? Suppose there is a simple question that there are two batteries of 6 volt and 6 volt whose positive terminals are connected to each other, then what will be the current in 10 ohm? Current in 10 ohm will be equal to 0. Okay, now we will discuss potentiometer. Now the red color diagram is basically our potentiometer. So this potentiometer has battery of EMF E, a resistor R which can be variable also, and a potentiometer wire AB whose VCM is given. So VCM is given in the question, and VCM is potential drop or voltage drop per unit length. Now there is a battery of EMF E1 whose internal resistance is R1, and there is a galvanometer. So we can move this arrow on this wire, and suppose at this point the current in galvanometer is 0 at this point at L1 from A. So for this small circuit we'll draw it like this. So for E1 we have E1, for resistor R1 there is R1, galvanometer is denoted by G, and the wire whose VCM is given and length L1 is given will replace it with a battery of VCM L1. Now we have already discussed that if current in this resistors are 0, then what is the condition? The condition is that the total EMF on top will be equal to total EMF in the bottom circuit. So E1 will be equal to VCM into L1. So if current in galvanometer is 0, it means current in R1 is also 0. It means the total increase in potential due to this battery will be equal to total decrease in potential in this wire, and the decrease in potential will be VCM into L1. So we can write E1 will be equal to VCM into L1, where VCM is potential drop per unit length for this wire. L1 is distance of this point. This point we'll call null point. Null point is a point when current in galvanometer is basically equal to 0. Similarly, suppose I connect a different battery of EMF E2, and in that case, suppose the null point is at L2. So we can write E2 equal to VCM into L2, where VCM is potential drop per unit length, L2 is distance of null point from A, and E2 is EMF of second battery. So what we'll do is we'll divide both these equations, and E1 by E2 will be equal to L1 by L2 because VCM will get cancelled out. So to remember this equation to compare EMF. So suppose if E1 is given, L1 and L2 we can calculate with the help of scale, then E2 can be easily calculated. So remember this thing, that the potentiometer depends on the working principle of potential drop per unit length. That more the length, more will be the potential drop, because potential drop is directly proportional to length of wire. Okay, so if you now we'll discuss one numerical this. Suppose in this potentiometer, suppose for E1, which is 2 volt, suppose L1 is given to be 100 centimeter. For E1, the null point is at 100 centimeter, and for E2, the null point is at 50 centimeter. So we have to find out the value of E2. So we can use the equation for comparison of EMF, that is E1 by E2 will be equal to L1 by L2. So putting all the values, the EMF will come out to be 1 volt. Now remember this thing, if someone asks you how will the null point get affected if internal resistance changes, if you can see the null point means L1 and L2 does not depend on R1 or R2. So if R1 will increase or decrease, it will not affect the null point. Remember this thing. But if you will increase the length of this potentiometer wire, then definitely there will be change in the null point. Okay, now what you have to do is I am sending you a sheet today in which there are close to 8-10 questions of potentiometer to compare EMF. You have to solve, and if you have any doubt, you can send me. Okay, bye bye.